Hello and welcome to another pre-calculus. We're going to be working with Unit 3, Topic 1. So special angles and reciprocal trigonometric functions 12. So it says the graph of y is equal to secant of x has the same asymptotes as which of the following graphs? Circle the letter of the correct answer. So when we're talking about asymptotes, we're talking about which values does this not equal to. So for example, right, so y is equal to secant of x. So secant of x is another way of saying 1 over cosine of x. So really what we're trying to say here is what values in a sense give us 1 over 0. So also think about when is cosine equal to 0. That would be x is equal to pi over 2 and 3 pi over 2. So to think about which other values have asymptotes, cosine normally does not have an asymptote, neither does sine. Now, it deals with either tangent or cotangent or cosecant, but the thing about cosecant is really going to be 1 over sine, and when is sine of x going to be equal to 0? And that's when it's going to be 0 and pi. So this one is out as well. So I'm left with either cotangent or tangent. Now, when I think about tangent to begin with, isn't that really saying sine of x over cosine of x? So that goes along the lines of the same having cosine in the denominator or having a 0 for the denominator, so D is your answer. That is going to be at pi over 2, 3 pi over 2, and any, in a sense, multiple of that, 5 pi over 2, 7 pi over 2, or the negative versions, the negative pi over 2, the negative 3 pi over 2. Okay, so in each blank, write the names of the function in the box below that has the given characteristics. Each function is used more than once. So where's the amplitude for? So that would be the value that is in front. It could be positive or negative. So that would be j of x. So where's the period equal to 2? So a couple things to kind of take note. Right, there is a b value for these types of problems. So b is equal to 2 pi divided by the period. So if I know the period is in a sense 2, I can write this as 2 pi over 2. And so the 2's cancel, I'm left with pi. So I'm looking for the value that is in a sense in front of the x. So if I look at the value in front of the x here, that's 3, that's 2/3, that's negative, that's 3, and in this case, even though the pi is on the outside, right, this pi is technically in front of the x, so this would be k of x. So the range is all real numbers for y such that it's from 2 to 8. So that means that the max here is going to be 8, the minimum is going to be 2. So a couple things that I can use to help me along with this. This deals with both the amplitude and also the midline. So if I think about how this goes, right? So I can try and maybe set up the graph. I don't know what the high or low values are, so I'm just going to put it kind of just anywhere. So I'm going to put this like this. I do know the middle line in between these two. So if I do this, ready, I'm going to take the max minus the min divided by 2. So it gives us 6 divided by 2, which gives us 3. So that means it's 3 units in this direction, 3 units in this direction. And I can figure out my midline by taking the minimum, adding the a value, which is 3. So this is going to be at 5. Now, there could be a couple different values that are kind of set up like this, but I'm really looking for a midline that has 5, and I'm looking for an amplitude that has 3. So it looks like that there's only really one equation that has that, which is going to be f of x. So f of x is going to go right here. And lastly, the graph of the intersection of the x-axis is going to be at 3 pi and then 0. So looking at this specific type of problem, there could be many different solutions for this. Um, I'm trying to think of maybe a little bit of an easier way to write these down rather than testing each one, because that's going to get kind of tedious to kind of go from that. But I might get to the point where I might have to do this. So each function may be used more than once. So I'm going to write this down as, let's see, let's test g of x, for example. So I'm going to say 0 is equal to cosine of 2/3, type in 3 pi, minus, in a sense, pi, and see if I can get that value from there. So 0 is equal to cosine, the 3's cancel, so I'm left with 2 pi minus pi. And so cosine of pi, is that going to be equal to 0? Well, that checks out, so that's going to be g of x. Now, I got super lucky being able to figure that value out, but it always, actually, no, that is not equal to 0. I lied. So that does not check out. So that one is out. Let's see the next one, which one I can work with. I'm trying to find some values that might make it a little bit easier to solve for, especially if I'm, did they say each function, write the name of the function in the blank below. You can also graph each one of these functions and then figure out which one hits 3 pi. Are you allowed to use, nope, you're not allowed to use a calculator. Never mind. So I can say 0 is equal to sine of negative, then we can say negative 3 pi plus pi. So this would actually give me sine of negative 2 pi is equal to 0. So sine of negative 2 pi is actually going to be equal to 0, so that one checks out. So it is going to be h of x. A couple of things that help me figure out some of these problems. I can think about if this is going up and down, right? The y is going from 2 to 8. It will never actually hit the x-axis, so I know f of x is out. Just plugging in can certainly help out as well. I know right here we're going to end up getting some kind of weird values, especially if I end up doing 3 pi, place that into here, minus a half. That's going to get me some really kind of weird fractions, so it's not going to give me a perfect nice 0 for sine. I know right here that if I ended up putting in 3 pi into this, that would give me 6 pi times negative 4. Well, that would actually end up giving me negative 4 is actually going to be my answer to that. So it is actually just going to be h of k. So I would say for this, it's more about just kind of checking your answers. Plug in the x value, plug in the y value. Okay, so if cosine of theta is equal to 4/5 and sine of theta is equal to 5/4, or excuse me, cosine of theta is equal to 4/5 and sine of theta is equal to 3/5, compute each of the following values. You may use the unit circle to help you out. So what I'm going to do here is I'm going to create a triangle, more specifically a right triangle. Cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse, right? That's that good old SOHCAHTOA. So I can say that 5 is going to be here. The adjacent part is going to be 4, and then 3 is going to be here, which is our typical right triangle. And we're also talking about it being in the first quadrant because both sine and cosine are tangent, so all students take calculus. Now, cotangent, this goes by multiple different types of names, but the more specifically is 1 over tangent, or the reciprocal of tangent of theta. So if tangent, let's say tangent normally of theta is going to be the opposite over adjacent, so that's going to be 3 over 4. The cotangent is going to be 4 over 3. Okay, secant is another way of saying 1 over cosine of x, or cosine of theta in this example. So just the reciprocal of cosine, so that's going to be 5/4. Now, when I am dealing with sine of pi minus that specific value, what ends up happening is I end up getting something that looks like this. I end up getting, so I'm going to, so if this is in a sense my theta, that's my angle, and I take pi and subtract it from it, so this whole thing from right here to here, so from right here to here is pi, and I subtract this type of angle, it means that I'm subtracting, in a sense, that angle and figuring out this value from here to here. Well, I'm actually going to end up creating that same type of triangle over here on this side with still some of the same values. This is going to be 5, this is going to be 3, but this is going to be negative 4. So what I'm going to do here is I'm still going to say sine of pi minus theta. So that means that I'm at this terminal side right here because I subtracted this theta from there, but I'm still left with the same type of triangle. So that's still going to be 3/5. Okay, cosine, if I were to, in a sense, okay, so I'm going to erase some of these. if I add 2 pi to this, what ends up happening is I start here and then I go completely around again. And so I actually end up in that same location. So my answer is still going to be 4/5. And then tangent, if I were to do this, so I'm going to add a pi to this. So I'm going to say pi. So pi is going from there to there. And then that theta. So and then theta is going to be right here. It's going to draw that terminal side down there. Right, and then weirdly enough, yet again, I get that same type of triangle. This is going to be 5, this is going to be 3, this is going to be 4, but a couple things, right? That's going to be negative, that's going to be negative. And this is still going to be 3/4, opposite over adjacent. And we also know that tangent is supposed to be positive in that third quadrant. Okay, consider the sinusoidal function graph below. It says, which of the following functions could model this specific graph? Click all that apply. So what I'm going to do here is I'm going to get a couple values, just making sure that I am all kind of set. So the a value is, actually before I do the a value, I'm going to write down my max, my minimum, and my period. So these are all the parts from the graph that I want to make sure that I get. So the max is going to be 5, the minimum is going to be -1, and the period. So I'm looking at, in a sense, the value. Well, before I do that, yeah, let's do this, right? So the max right here is at 5. The minimum right here is at -1. So from here to here, in a sense, right, from here to there, is considered to be not just a full period, but half a period. So it looks like I'm going from 2, so 1, 2, 3, 4. So it looks like that going from the max to the min takes 4 units, but that's only half a period. How long does it take to get back up again? So that would be double that, so that would be 8. Okay, so then I'm going to say the amplitude. So the amplitude, so which is also known as my a value, we do max minus the min divided by 2. So that gives us 6 divided by 2, which gives me 3. What is my b value? Well, my b value is going to be 2 pi over the period. So that's going to be 2 pi over 8. So that's going to be pi over 4. And then I'm going to find out my d value. That's going to be the minimum plus the a value. So the minimum is -1 plus 3, which ends up giving us 2. So that's the information I want to drag about this. Now I get to kind of decide on how do I want to set this up. So if I know my midline is at 2, and I'm using, let's say, sine, I know that I start at actually 0 for my starting point, and it's going up, so I have a positive sign. So looking at the couple things, the amplitude is 3, the b value is pi over 4, and the d value is 2, so that works out perfectly. Now, cosine, if I start at this point right here, that means that it would be -2 for your phase shift, so it makes sense that that would be -2 with a pi over 4 on the outside. That would be 3 for the amplitude and 2, so that one actually works out as well. Now, for sine being negative, well, first of all, if we start at 2, sine normally doesn't start at a high point or a low point, so that one is out. If we work on to the next one, if I move +2, that means I'm moving 2 units in this direction to this point, which is my low point. That is definitely not where sine starts. But if I actually use this for cosine, right, being the +2, I have to make that value negative because it starts at a low point. If it starts at a high point, it is a positive cosine. If it starts at a low point, it is going to be a negative cosine. So that would be a check. Right, and they all have the corresponding amplitude and d values, also known as the midline or equilibrium. Okay, I am finished for the Unit 3 topic 1. If you have any questions, please comment down below or message me on Discord if you guys have any questions, and thanks for your time.